Hello friends, welcome to Shiksharthi. In this session, we shall be discussing logarithmic functions. So let's start. Now the prerequisite for this session is you should have the entire knowledge on functions. Now when I say entire knowledge, I am basically interested in you knowing how to find out the domain or what is the domain, how to find out the range or what is the range of the function, and then using domain and range to plot the graphs of the functions. And thereafter having some experiential learning from the plotting that you would have done. Okay, now when we talk about logarithmic functions, first we would talk about how to find out the domain and the range of the logarithmic functions by taking some examples, and then eventually we'll be plotting the graphs of the logarithmic functions as well. So here I am taking a logarithmic function which is given by gx is equal to log x to the base a. Now what is the base here? The base here is there could have been a base 10 or could be base 2 or could be any other base that can be taken when it comes to the value a. So the point to understand here is x is a variable and a is a constant term. A is a constant value. So let us start off this discussion by first finding out the domain of gx. So when we are finding out the domain of gx, there would be two aspects to this. One aspect is what is the value of the constant that you can take, the constant term. So we know that we cannot find out the value, the log of negative numbers. So in that case, a needs to be positive union with. When you are writing this as log x by log a, you will write this as log x by log a only once you have written the domain of the function first. If you recall, we have already talked about this in our sessions earlier or in our sessions on functions, etc., wherein we have talked about that before you perform any mathematical operation on a function, you first need to specify the domain. Now, when you're specifying the domain in case of logarithmic functions, you need to understand that the domain will even comprise of those values which are non-variable values. For example, when I say non-variable, I'm basically referring to a constant term a. Thereafter, we can talk about the variable values also. So, what is f of minus x? We know that we cannot find out the logarithmic values of negative. So this will not be defined. So we will highlight this by a 5. F of 0. Logarithmic function x is not defined for x is equal to 0. In that case, when we input f of plus x, can we input the value f of plus x here? Yes, of course. But in that case, what is going to be the outcome? We will talk about the outcomes as well. So let me add one more domain value here, which is x is greater than 0. So have we specified the domain of logarithm x to the base a? Yes, we have. And after we have specified the domain of this function, can we say that now, after we have specified the domain, can we say that fx is equal to log x by log a? We can. Now, here we would do two things. One is we would give different values to a and then find out the values. At the same time, we may give some different values to x as well. Okay, so if a is equal to 2 and x is equal to half, let's say, in that case, what is going to be the value of fx? So if we have taken the value of a as 2 and x is equal to half, in that case, we'll be able to say that this is nothing but log of half divided by log of 2, which is nothing but minus 1, because 2 to the power minus 1 can be written as minus 1 log 2. At the same time, we could have taken the value of a as 2 and x as 2 again. In that case, what is the value of fx? The value of fx will be log 2 divided by log 2, which is equal to plus 1. So let's say if and then we are finding out the values of fx. Incidentally, we should have taken the value here as gx, not fx, because the original function that we have taken here is gx. So let me change this for you. So let's say then the value of gx here, Now moving forward, if we would have taken the value of a as minus 1 by 2 and x as 1 by 2, a as 1 by 2 and x as 1 by 2, we know that a cannot be taken here as negative, and the other set of value that I would take here is a is equal to 1 by 2 and x is 2. In that case, let us find out what is going to be the value of gx in both the cases. So in the first case, gx will be log of half divided by log of half, which is nothing but plus 1. In the second case, the value of gx will be log of 2 divided by log of half, and by now we have realized that log of a positive proper fraction is negative. Okay, can I say that this is equal to minus 1? Okay, finally the points to be noted. So when we are talking about the domain would be the domain values, the domain would be a is greater than 0, because we know that we cannot find out the log of negative values. At the same time, a cannot be equal to 1, because when we are talking about log x upon log a, and we know that by now or even if we do not know, we can write it down separately somewhere. So log 1 to the base 10 is equal to a 0. This is an important point to be noted. And along with this, can we take all such values of x? No, we can take only positive values of x. But when we are talking about the range, we see that, did we get a 0? Yes. When did we get a 0? When we had taken the value of, let's say, x is equal to 1, and in that case we had taken the value of a as 10. So what is the range? Range is y is greater than minus infinity and less than plus infinity. Can we plot the graphs? Yes, we can plot the graphs. Why are we plotting two graphs? Because we had taken two different values of a. So in the first case, what are we going to do? We are going to, let's say, plot the graph. Here we are going to plot the graph log of x to the base half, and in this case we are going to plot log x to the base 2. What are the values that we are expected to take here? So I would suggest take x is equal to 0. Can you take x is equal to 0? No, you can't. So take x is equal to half. The examples that we had taken. Take x is equal to 1 and take x is equal to 2 in both the cases. Half 1 and 2. So now in the first case, and then we would plot the graph. So now if I would have taken the value of x as half, given a is equal to 2, what is the value that I'm expected to get? I'm expected to get a -1. So let me write down these values as well. For example, here let's say I'm getting a -1. -1. Here we know that we have a 0. Okay. And let me write down one more value here. Let's say +1. And I'm using every bit of the discussion that I have had with you. So there is nothing that I am discussing with you which I have not discussed in this session. So coming back, when we are discussing the graph of log x to the base 2, let us refer to these set of values that we have already written here. So in that case, when x is equal to half, we are getting it as -1. At x is equal to 1, we are getting a 0. And at x is equal to 2, we are getting a 1. Now here in the other graph, when we are talking the graph of log of x to the base half, when we take x is equal to half, in that case the answer is +1. When we take x is equal to 1, irrespective of the base, whether you take it as 1/2 or 2, the answer is going to be a 0. When you take the value of x as 2, refer to the values on the left hand side, you get it as -1. Now we have to join these 3 points with the help of a relevant graph, and the graph here is going to be a non-linear graph, because logarithmic function is not a linear function, it is a non-linear function. Once you know this, it becomes easier for you to join these values with the help of a graph which will go through all these values and it will be concave downwards. Let me join these values once again. So this is the kind of a graph that you're going to get here, which was concave downwards, and the graph that you're going to get here is a graph which would be concave upwards. This is a freehand drawing, so makes it slightly difficult to draw the graph accurately. So please remember that the graph of log x to the base 2 is a non-linear graph which is concave downward. Concave downward means a graph which faces down. And log x to the base 1/2 is a kind of a graph which is concave upward because it faces upwards. And one more thing that you need to make a note of this here is the graph in either of the cases is not going to intersect with the line x is equal to 0, which is the y-axis, because x is equal to 0 is not a part of the domain. But when we talk about is the graph of log x to the base a, whether a is 2 or 1/2, is it going to intersect with the real x-axis, which is the line y is equal to 0? Yes, of course, because y is equal to 0 is a part of its range. Quickly, so if I take a log of a positive proper fraction, pf here is a proper fraction. Let's say to the base 10. Okay, so when we are taking the log of a positive proper fraction to the base 10, in that case the answer is negative. When we are taking the log of a positive proper fraction, a positive improper fraction, for example a value which is greater than 1, to the base 10, the answer is positive. And when you take the log of 1 is 0. Finally, when you take log of, let us say, a positive proper fraction to the base 1/10, positive proper fraction is a fraction which lies between 0 and 1. is a value which lies between 0 and 1. For example, the value x is equal to half is a positive proper fraction. Here the answer will be positive. And when you take the log of a positive improper fraction, an improper fraction is a positive improper fraction is a fraction which is greater than plus 1 to the base 1 by 10. Refer to the graph, and from here you'll be able to say that the answer is negative. Hope you will understand this and take your learning to the next level.